Hi, I'm Dr. Payal Dande. Welcome to the learning episode of B.Pharm on a stimulating unit of glycosides 1, which is an interesting and introductory unit of the section of Chemistry of Natural Products in 3rd semester of B.Pharm. Let's first have a look onto our contents and the learning objectives. Module 1 will discuss about the introduction of glycoside. Module 2 will talk about the classification of glycosides. Module 3 is going to talk about the methods of isolation, whereas Module 4 would tell about the alpha and beta D-methyl glycosides. Module 5 will talk about the important alcoholic glycosides such as salicine. Module 6 is going to talk about cyanogenetic glycosides such as amygdaline, and Module 7 will talk about the arbutin. To start with, let's first understand the definition of glycosides. I'm sure you all know that the plants contain many organic compounds of therapeutic significance, and one of them is glycosides. Glycosides are basically the organic compounds from the plants and animal sources, which on either acid or enzymatic hydrolysis give one or more sugar moieties. The sugar moiety as well as the non-sugar moiety. The sugar moiety is called as glycon, whereas the non-sugar moiety is called as aglycon and sometimes even referred as genin. Generally, the two are attached with a glycosidic bond that is formed with the loss of water molecule. They are considered as the condensation product of sugars. Thus, they form either acetals or sugar ethers by interaction of hydroxyl group and hydrogen from sugar and non-sugar moiety. The sugar molecule present in the glycoside may be one or more than one. Similarly, it may include the same type of such as beta-D-glucoside or different sugar moieties such as rhamnose, mannose, galactose, digitoxose, etc. Sometimes it also involves uronic acid such as glucouronic acid. Now let's talk about the general characteristics of glycosides. Glycosides are generally amorphous and sometimes crystalline substances which are soluble in alcohol as well as water, but they are insoluble in the chloroform and ether. They are named on the basis of source and may end up with IN. Example, cinegrine, digoxin, salicin, and so on. However, systemic name is formed by changing suffix, that is, OSE will change to OSIDE. For example, senosides, cascarosides, etc. They are usually accompanied by the hydrolytic enzymes in plants. As such, glycosides get easily hydrolyzed by acids, alkali, and even enzymes. The aglycon moiety separated after hydrolysis is non-polar in nature and thus gets soluble in non-polar solvent like chloroform and benzene. They are optically active and generally are levorotatory in nature. Although glycosides contain sugar moiety, however, the physical, chemical as well as the therapeutic significance is based on the aglycon part. In order to exert physiological effect, glycosides have to get hydrolyzed. That is, sugar in glycoside only helps in absorption and further facilitates the aglycon part to reach the site of action. The presence of glycoside is tested by using Fehling solution in the general test. They give the test positive only after they are hydrolyzed using mineral acids. They are believed to be involved in regulating growth and protecting the plant. Now let's talk about the classification of glycosides. Glycosides can be classified in several ways. They are classified based on the chemical nature of the aglycon moiety or based on the therapeutic significance, can even be classified based on the presence of sugar or glycon moiety, and also on the basis of linkage across the glycon and aglycon part. Now let's try and understand the classification of glycoside based on the aglycon moiety. According to the chemical nature of aglycon moiety, there are following types of glycosides, such as first, anthraquinone glycoside, sterol or cardiac glycosides, saponin glycosides, bitter glycosides, coumarin glycosides, cyanogenetic glycosides, flavonoid glycosides, isothiocyanate glycosides, aldehyde glycosides, phenol glycosides, steroidal glycoalkaloids. Let us now recognize the basic glycon skeleton and the example of each type of glycoside with their plant source. The details of each is enlisted in the table which is shown on your screen. Now let us first understand the anthraquinone, where you can find the 3-benzene ring and the 2 oxygen which are bonded on the central benzene ring. The example of such anthraquinone glycosides can be seen in the plants such as senna, aloe, cascara, and they are named as senosides, barbaloin from aloe, and cascarosides from cascara. Now coming to the second type of glycoside, which are known as cardiac glycoside, you will find the 3-benzene ring and the 2 pentane rings are there. Along with that, you will also find an oxygen attached in the pentane ring. Now such type of glycosides are mainly found in the digitalis species such as digitalis purpurea, where you will be getting digitoxin. Digoxin is found in digitalis lanata, and similarly we also have stropanthoside in the Strophanthus species. The next in the category is steroidal glycoside, where the 4 rings are compulsory, and the example is diosine, which is found in the Dioscorea species. Similarly, another example, solasonine, which are found in the Solanum species. Coming to the fourth type of glycoside are very important ones, the triterpenic glycosides, which have C30 carbon atoms and 5 benzene rings, which is a very important character of their glycon ring. Examples are ginsenoside, which are found in ginseng, glycyrrhizine, which is found in Glycyrrhiza glabra, which is commonly known as licorice, senegin, which are found in the plant Seneca. The next important glycoside is cyanogenetic glycosides, which are mostly found in bitter almond like amygdalene and prunacin, which are found in wild cherry. The next is isothiocyanate glycoside, which is found as cinegreen in black mustard and cinalbine in white mustard. Then we have flavonoid glycosides, which are commonly found as rutin in buckwheat, and we have coumarin, where the examples are soralane in soralia and bergaptane in bergamot. Followed by this, we have the chromone glycosides, where we have kaolin as an example coming from Amymesis and visnagine from Amyvisnaca. We have bitter glycosides in Quassia plant, example is quercetin. We have lactones such as monoterpene lactones, which are found in gentian plant known as gentiopicrine. Similarly, we have diterpene lactones, which are found in kalmeg plant, which is known as an antihypertensive plant, and the main content lactone is andrographoloid. Followed by this, we have other types of glycosides such as phenolic glycosides, where we have arbutin as an example, which we are going to study in detail later. Similarly, we have aldehyde, where glucovanillin is an example. Alcohol, salicine, which we are going to study in detail later. And similarly, we have some tannins also included in glycosides such as epicatechin gallate. The next classification is based on glycon moiety. Glycosides are also classified based on the sugar or glycon present in their structure. Sugar in glycosides are of different types, but mainly it is beta-D glucose. Other sugars are also present such as galactose, fucose, mannose, rhamnose, digitoxose, cymarose. Now based on the sugar moiety, they are known as glucosides if the sugar moiety present is glucose. We can call it rhamnosides if the sugar moiety present is rhamnose. We call it as pentosides if the sugar moiety present is pentose type, example ribose. And in few cases, the sugar present is either digitoxose or cymarose. Now let's come to the third classification, which is based on the basis of linkage between glycon and aglycon part. Now over here, the first one is O-glycosides. In such glycosides, the anomeric carbon of sugar part is always linked with alcoholic or phenolic hydroxyl or either carboxyl group, and an example for this is senoside, which is known as O-glycoside, which you can see in the structure, where the glycon is attached and a water molecule is coming out, that is, and the glycon is getting connected to the A-glycon by oxygen. The next we have S-glycoside. In such glycosides, the anomeric carbon of sugar moiety is attached to a sulfur atom of A-glycon. They are also known as thioglycosides. Example, cinegrine from black mustard. Over here in the structure, you can see that the connection of glycon to the A-glycon is through sulfur. The third type is N-glycoside. In such type of glycoside, the anomeric carbon of sugar is always linked with the nitrogen atom of NH2 or NH, that is amino group of A-glycon, like we see in nucleosides, either DNA or RNA. They are more appropriately known as glucosamines. The next we have C-glycosides. In such glycosides, the sugar is linked or condensed directly to carbon atom of A-glycon. The anthraquinone glycosides from aloe, which is known as barbolin, is the example of C-glycosides. Similarly, cascarosides are the example of both O as well as C-glycoside. Now let's see the last classification based on the therapeutic activity. Based on the pharmacological effect exerted by the glycosides, they are majorly classified as cardiac glycoside, where we have examples such as desoxygenin coming from digitalis leaves. Similarly, laxatives or purgative glycoside such as senoside A and B coming from senna leaves. Anti-inflammatory glycoside such as salicine, which comes from willow or salix bark. Anti-ulcer glycosides, the examples are glycyrrhizine from licorice root, and bitter glycoside, which comes as quercetin from quercia wood. There is also local irritant glycosides, for example cinegrine, which comes from black mustard seeds. Now let's move on to the next module, which talks about the method of isolation. The general method by which glycoside is extracted and isolated is termed as Tass-Otto method. First, a fine powder of the plant drug containing glycoside is made and extracted using suitable solvents using the appropriate method of extraction. As glycosides are polar in nature, you can either use alcohol or water. Both are most preferable solvent used for the extraction. Care has to be taken to keep the temperature below 45 degrees centigrade while extracting the thermolabile glycosides. The extract is further treated with lead acetate to precipitate the tannins and even filtered. The excess of the lead can be precipitated in the form of lead sulfide by passing hydrogen sulfide gas over the filtrate. The filtered extract is now concentrated to get the crude glycosides. The filtrate is further subjected to fractional solubility, crystallization, distillation to get the pure glycoside. These are further purified, separated and isolated using various chromatographic techniques. The isolated and purified glycosides are then characterized using advanced analytical instruments such as IR spectrophotometer, UV visible, NMR and mass spectroscopy, etc. Now let's talk about the alpha and beta D-methyl glucosides. As we discussed earlier, that glycosides are formed with the hydroxyl linkage between sugar and non-sugar moiety. Now it is seen that D-glucose is most commonly involved in the biosynthesis of glycosides. They are known as alpha as well as beta D-methyl glucosides based on the stereoisomers which are involved in the linkage. The simplest way to synthesize glycoside with two isomers is by reacting the methyl alcohol and glucose. It is believed that the plants majorly contain beta-D glycosides. However, according to the chemical reaction proposed by Stephen and William, when a monosaccharide reacts with an alcohol in the presence of an acid catalyst, anomeric methyl glucoside formed is an equilibrium ratio having 66% of alpha to 34% of beta-D methyl glycoside. The diether product, which is known as glycoside, is formed. It is stable to the base as well as to the alkaline oxidants such as toluene's reagent. Dear friends, so far you have got a fair idea about the definition of glycoside, the general characteristics, the different criteria of its classification, the methods of its isolation, as well as the two types, that is alpha and beta glycoside. If you have missed anything of this module or contents, you may log on to our website www.cec.nic.in to download videos, FAQs, LOR and other contents so that you can stay updated with this chapter. Now let's move ahead to our next module, which is going to give details of the various types of glycosides and their therapeutic significances. The first to start with is the alcoholic glycoside, and the salicin is the most famous alcoholic glycoside ever known to our world. Salicin is the most important example of an alcoholic glycoside because it is obtained from the various species of salix plant commonly known as willow bark. The other sources from where the salicins can be obtained are Populus and Castoreum species. The drug has been mentioned in several ancient texts from Egypt, Greece, Assyria and Sumer. Sometimes even Native Americans have used these for the medical treatments. Now let us understand its history. The medicinal properties of this plant was first evaluated and reported by the scientist known as Edward Stone, and this was in 1763. Salicin, the active extract of the bark, was further isolated by a French pharmacist called Henri Leroux in 1828. Later, an Italian chemist known as Raffaele Peria separated the compound in its pure form. The synthetic version of salicin with lesser side effect was made in 1897 by Felix Hoffmann. This compound later got famous in the name of aspirin and led to the beginning of an important class of drugs known as NSAIDs, non-steroidal anti-inflammatory drugs. Now let's understand its mechanism of action. Salicin, after it gets into the body, can be converted into salicylic acid, which is closely related to the aspirin, and it exerts the analgesic, antipyretic as well as anti-inflammatory effects. It can also be used as a topical anti-inflammatory agent. It is highly bitter in taste. High doses of salicin may even prove to be toxic and damage kidneys, may cause stomach ulcer, diarrhea, bleeding and even digestive discomfort. Some people may get allergic or sensitive to salicylates, very similar to the reactions to aspirin. Salicin is being further investigated for its use in the treatment of atopic dermatitis, skin allergies of type 1 and type 4, diaper rash, herpes, inflammation and even sunburn. Before we move on to our next module on cyanogenetic glycosides, we'll quickly recap the topics we have learned till now. Let's see, we discussed about the chemistry of glycosides, right? The different types of glycosides based on the glycon structure and the most important glycoside known as salicin. Now that we are familiar with their types, let's learn about the therapeutic significance of those glycosides. The next in the list is cyanogenetic glycosides. Cyanogenetic glycosides are even called as cyanophoric glycosides. These are O glycosides containing nitrogen heteroatom in the form of C double bond N. They are commonly known as cyanophore or cyanogenetic glycoside because of the presence of hydrocyanic acid. They are reported in about 80 families of the plants. Many of them are derived from the nitrile of mandelic acid. On hydrolysis, such type of glycosides yield either prussic acid or hydrocyanic acid and benzaldehyde. Presence of hydrocyanic acid as a glycon is very important criteria of chemotaxonomical significance in such plants. Let's see an example. Prunus amygdalis with a variety of amara is a variety of bitter almond that contains the HCN, that is the hydrocyanic acid, while the Prunus amygdalis with a variety of dulcet does not contain hydrocyanic acid. Now let's see. About 110 plant families contain cyanogenetic glycosides. and they are prominently found in the wilting leaves and fruits of various families such as Rosaceae, having the plants such as cherries, apples, plums, almonds, peaches, apricots, raspberries, and even crab apples. They have diverse pharmaceutical significance. Some of them are used as flavoring agents. Amygdalene from bitter almonds, prunacine from wild cherry bark, linamarin from linseed are some of the most important cyanogenetic glycosides. They are identified by the liberation of hydrocyanuric acid on hydrolysis. Some of the important chemical tests are mentioned to understand the presence of cyanogenetic glycoside in the plants. Let us see the first test, which is called as sodium picrate test, where we have to first moisten the crude drug material with water, and then further you have to add dilute sulfuric acid. Heat the flask gently, suspend a strip of sodium picrate paper at the neck of the flask. If you see the yellow color of paper turning into brick red color, then it signifies the presence of cyanogenetic glycoside. The liberated hydrocyanic acid turns the sodium picrate to sodium isopurpurate and gives it the red color. The intensity of color produced with picric acid can also be used for semi-quantitative analysis, that is, darker the color, more the cyanogenetic glycoside. In another test, a paper strip treated with alcoholic solution of guaiacum resin and then copper sulfate solution is suspended, which turns blue due to the presence of hydrocyanic acid. Bitter almonds have amygdalene, which is a cyanogenetic glycoside, which is found in many plants, especially in the seeds, that is in the kernels of bitter almond, apricot, plum, and even peach. It was first isolated in 1830 from Prunus amygdalis var. Amara, commonly known as bitter almond. Amygdalene is extracted from the almond or apricot kernels by boiling in ethanol. On evaporation of the solution, we have to add diethyl ether. Amygdalene is precipitate as white minute crystals. It is used mainly as aquamydalene in bronchitis, vomiting, nausea, and even in conjunctivitis because of the presence of hydrocyanic acid. The hydrocyanic acid is a strong cell poison. Its LD50, that is lethal dose, is 50 mg, and hence it should be used in a very small concentration. Both amygdalene and its modified form, which is named as letril or even called as vitamin B17, have been promoted as cancer cures. Now let's go to the next important glycoside known as arbutin. It's a glycosylated hydroquinone glycoside. It was first extracted from the berberry plant in the genus Arctostaphylos. Arbutin is found in wheat and is concentrated in even pear skins. It is also found in Bergenia crassifolia. Arbutin was also produced by an in vitro culture of Schisandra chinensis. Pure arbutin can be prepared synthetically from the reaction of acetobromoglucose and hydroquinone in the presence of alkali. Arbutin was found in the berberry plant and it's used traditionally in the treatment for urinary tract infections. There are various uses of arbutin. It is used as a skin lightening agent. It inhibits tyrosinase and thus prevent the formation of melanin pigments. Some in vitro studies of human melanocytes exposed to arbutin at concentrations below 300 microgram per ml has reported decreased tyrosinase activity and melanin content with little evidence of cytotoxicity. So to conclude, we in this present discussion has learned about the glycosides, their general characteristics, the various modes used to classify the glycosides. Further, we also discussed about the method of its extraction, isolation, and also learned about the important classification of glycosides based on the glycan structure. I am sure it was interesting to know about the therapeutic significance of important compounds like salicine, synegrine, and arbutin. With all the above information, now we come to the end of today's lecture. Do keep in mind what we discussed today. It's time for you all to do some self-study. This is Payal Dande signing off. I'll be back with one more lecture in this series, which would be known as Glycoside 2. If you want to learn more and enhance your knowledge, you may log on to our website for MCQs, quizzes, LORs, and our website is www.cec.nic.in. Till then, keep studying. Goodbye.